Hi. The experiment what we are going to see is Planck's constant, determination of Planck's constant by using LED. For this, first we have to discuss the theory behind this experiment. So we are going to use LED. So we are going to start with PN junction. So this is P region and this is N region. When the diode is unbiased, the electron will be in the valence band of N region, and then the conduction band will be empty. So now we are going to apply a voltage across the LED. For example, we are going to apply the voltage V as 0 volt. So when the voltage is 0 volt, what happens is there is no energy for the electron to move from valence band to conduction band. So now we are going to increase the voltage. So we are going to increase the voltage as 1 volt, for example. So if voltage is 1 volt, then the energy E is nothing but E into V, charge of electron into voltage, that is energy. Okay. So now in this case, if this E is less than Eg, so we assume that in this case this E is less than Eg. Okay. So now what happens? The energy supplied is less than the band gap. So there will be no electron in the conduction band. For example, when voltage is Vk, I just write it as voltage what we are applying V as Vk. Now what happens is this energy E will be equal to Eg. So that I will write here K. Okay, the energy corresponding to applied voltage Vk is Vk. This is equal to Eg. Now what will happen is the electron from the valence band is having sufficient energy to move to the conduction band. So already it is biased and it will be in forward bias. So the electron will move to the depletion region. As you know the theory, what will happen is in the depletion region it will recombine with the hole in the valence band. So when it recombines, it will emit the difference of energy in the form of a photon, h nu. Okay, so you know that this h nu will be equal to Eg. So from this equation we can write this, from this and from this we can write that the Ek is nothing but EVk and this is equal to h nu. From this we can find h equal to EVk by nu. But we know that this nu equal to C by lambda. So I am going to write this equation h equal to E Vk lambda by C. So this is the formula what we are going to use to find Planck's constant by using LED. From the theory, we have this equation h equal to E Vk lambda by C. Here E is the charge of electron 1.6 × 10⁻19 coulombs and lambda is the wavelength of the light emitted and C is the velocity of light. So we know this E, we know this C and this lambda from the manufacture of the LED we will get it. What is the wavelength of the LED? Only we have to find Vk. For this we are going to use forward bias circuit. So forward bias circuit, you have a LED. So this is the symbol of LED and the positive terminal of the LED we are going to connect it to the positive terminal of the power supply. So that is forward bias. And then we have to close the circuit. So any circuit, if it is a closed circuit, then only it will work. So while doing practical, you have to check whether the circuit is closed or not. So when it is forward bias, you are shorting the So we have to apply voltage. The applied voltage is Vs, source voltage, and we have to measure voltage across the diode. So for that we have to connect a voltmeter across the diode, and the voltmeter should be connected in parallel, and we have to measure the current through the diode. So for that I am going to have a ammeter here. Ammeter should be always connected in series. So again, this is positive, negative. So this is the circuit. From the circuit, this Vd is the voltage across the diode. Vs is the applied voltage. The current Id is the current flowing through the diode. So we have to measure serial number, Vs applied voltage, voltage across the diode, and current through the diode. So initially the applied voltage will be 0, and the voltage across the diode will also be 0, and the current will also be 0. There is no any hard and fast rule. So what should be the range? So you can increase the voltage as 0.1, 0.2, 0.3 like that. So what should be the range? Range depends upon the diode. So generally what you can do is you can take it as 0.5, 1 volt, 1.5, 2 like this. You can apply the voltage across the diode. And whatever voltage you observe here, that you have to write it here. And the current also, whatever you observe, you have to write it here. Okay. So this is how you have to do the experiment. Now let me explain the sample ratings. So this, when a LED is given, you have to connect the circuit, and all LED will glow within 5 minutes. So once you connect the circuit, slowly you adjust the input voltage so that at some point the LED will glow. So based on that you can choose the range. So for example, red color LED, it will glow within 2 volt. So I have taken 0.2, 0.4, 0.6, 0.8 like that, the input voltage. For any LED, if it is 3 volts means you can take 0.5, 1, 1.5 like that. Depending upon the LED, you have to choose the range. So this is the sample reading. So here you can see that this is the applied voltage. So up to 1.6, the applied voltage and the voltage across the diode is same, almost same. And the current is 0. So after 1.6, the current starts flowing. That means the electron moves from the valence band to the conduction band. Okay, and started moving from the valence band to conduction band. So after that, whatever the applied voltage is, the voltage across the diode will remain constant. Okay, so this, if you plot it in a graph, so you have to plot a graph between voltage and current. So voltage and current I. Okay, so voltage in volts, current in milliamps. So as from this plot, you can see that up to 1.8, there will be no current. The current will be 0 up to some 1.8. After 1.8, what happens? The current starts increasing, and if you go beyond this, the current will increase very sharply. So this is the plot. So from this plot, you have to extend this line. You have to plot the graph. You will get this graph. In this graph, you have to extend this line. So you should have a scale and draw it like this. So where this cuts, that is your knee voltage V. Now we know the knee voltage. So this, using this formula, you can substitute these values and you can find the Planck's constant. So from the graph we can find Vk, knee voltage. So for example, here I have taken the knee voltage as 1.8 volt. So E 1.6 into 10 power minus 19 heat into this lambda. This is actually we have taken it for red LED. The wavelength is given 660 nanometers. So 10 power minus 9 meters and 3 into 10 power 8 velocity of the light. If you substitute this and if you calculate, you will get 6.33 into 10 power minus 34 joule second. So this is the way you have to do the experiment. How to find the terminal of the LED? So very simple. By seeing through, if the LED is visible, this portion it will be very thin. That will be positive terminal anode, and the bigger one will be cathode. Another way also we can check that where the length is more, that is anode, the shorter one is cathode. If both are equal length, then how to find it? By using multimeter you can find it. Just take a multimeter and the positive multimeter, if you connect here, and the ground if you connect here with the multimeter, then the LED will glow. So this way also you can find which is anode, which is cathode. This is the LED. You can see that one end is short, another end is long. So this long one is positive and the short one is negative. If both the ends are equal, then how to do it? Just take a multimeter and keep it in the continuity tester mode, and if you connect the LED like this, it's not glowing now, so I will change it. Now it is glowing. So where this red one is there, that one is positive. So these are the different LEDs what we have: blue color, red color, green LED, yellow LED and IR. The wavelengths are given here. For blue color it is 460 nanometers, red it is 660 nanometers, green 520 nanometers, yellow 580 nanometers, IR it is unknown, we have to find it. And here is the resistor. The experimental part, we have regulated power supply, a digital voltmeter, and I have connected a multimeter for millimeter. I have made the circuit on a breadboard. So now we will see the circuit. The positive terminal of the power supply is connected to the resistor here, and on the another end of the resistor is connected to positive of the diode. The negative of the diode is connected to the positive of the ammeter. The negative of the ammeter is connected to the ground. Voltmeter is connected parallel to the LED. Before starting next, to check the circuit, switch on the power supply. So now I am going to adjust the source voltage. I am just keep on increasing it. The LED is not glowing. So it is 0.7, 0.8 volt, 0.9 volt, 1 volt, 1.1 volt. Then also the LED is not glowing. So randomly I am checking it. 1.4, 1.6. Now you can see that the LED starts glowing. So for 1.7 volt the LED starts glowing. So based on this we can decide the increment. So it is 1.6. We can take the applied voltage increment as 0.2 volt, 0.4, 0.6 like that. So the actual experiment, what you have to do is you have to start from the 0. The applied voltage is 0. The voltage across the diode is 0, and the current is also 0. So I am going to increase, I am going to have the applied voltage as 0.2 and the current is 0, the LED is not glowing, and the voltage across the diode. In the tabular column you have to enter this 1.8 as the voltage across the diode and 0 is the current. So now I am going to increase it to 0.4. So again note down what is the current. Current is 0. Your volt is 0.24 volt. 0.4, keep it as 0.6, then note down the reading. 0.8, 0.8, 1, 1.2, 1.4. So like this you can have, and the corresponding voltage across the diode you have to measure. So you can see here now 1.4 the current is 0. So when you increase up to 1.6 the current starts flowing. It is 0.014. I have kept in millivolts, 0.014 millivolts. Now the voltage is 1.6 across 1.4 across the diode. The current is 0.014 milliamps and the LED started glowing. Next is 1.8. The LED is glowing and the current is 0.102. Now the voltage is 1.73. And you can see that whatever the input voltage, I am just increasing 2.2, 2.4, the voltage across the diode will remain constant and the current will increase and the LED will glow. So this is how you have to take the observation as we discussed on the board. In that way you have to plot the graph and you have to do the calculation. Thank you.